Hi, everybody. We're doing P.7, which is right variable expressions for arithmetic sequences. I would like to have done this a little differently, but they really made a very narrow type of question here. So I'm going to go ahead and explain just how to do them. I'll reserve my long-winded explanation for a different one. So this is P7. I will give you the short version of where you could think of this as coming from. Basically, what we're looking for is y, oops, we want an equation kind of like y equals mx plus b. The problem is that they're going to, in each case, we can see that the change is +1 every time. And that's going to be the case for all of these. So we really don't need this equation, but we could, if we wanted to, think of this as 143 and 244 and 345 and so on. And we could use these 2 points to get this equation, which is really what they're looking for. The thing is that in every case, they're giving us m equal to 1. So in every case, we're talking about n plus the original zero term. Well, again, they made it really easy because you don't have to go through all of this and the y equals mx plus b in order to find it. All you have to do is look back one term. So one term before this is 42. And we can see that we sometimes call that the zero term. So if I add 1 plus 42, I get the first term, which is 43. If I add 2 plus 42, I get the second term, which is 44, and so on. This is coming from here, but you don't need any of it in order to answer the question. You just have to go one before and add it to n. So it's going to be, in this particular case, n plus 42. I would have loved to go into detail in why, how it works, but you don't need it. Now, the other type that you're going to get are where they have a multiplier. And in this case, your b is equal to 0. So basically, you're looking at y equals mx. There is no original term because they just made it easier. We're multiplying a number by n to get these. And the first one is -20. So clearly, we're talking about -20n. And that's going to give you -20 for the first term. And then when you put the n equal to 2, you get -40. And when you put the n equal to 3, you get -60. So these are the only two expressions that they're talking about, mx or x plus b. These are the two types of y values that they're talking about, or in this case, n values. So this is going to be -20n. Maybe they'll give us a more interesting one at the end, but I suspect they won't. Notice that these are going up by 1. They're increasing by 1 every time. So basically what we're looking for, and I'm just going to simplify this all the way down, we're looking for what we call the zero, I'll say zeroth term instead of the first term or the second term or whatever. And that's the one that came before that, which is -86. And if you add that to n, you end up with the expression that you need. So that's n, and we usually just write -86. That's all. It's that easy. This one's a multiplier. We're multiplying by 2. 2 times 2, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and so on. So this is just 2n. This one is a sequence, one after the other. So we need n plus the original, which was the zero term, which was 35, the term that came before the 36. These could have been made much, much more difficult. I suspect that in some textbooks and so on, where you may be practicing from, they're going to be more complex. But for these, we'll just do them ourselves. 39 is the multiplier. We're multiplying by 39, so it's just 39n. We're adding 1 every time. So we need the zeroth term. To get to, one way to think of it is n plus my zeroth term, which is -6, -8, gives us the -7. So if I want the first term, it's going to give me my -7 and so on. So it's n minus 8. I was thinking I could make that simpler, but not really. You just have to go to the zeroth term. Now this one this is a multiplier. You can see that we multiplied by -2 every time. So the increase, in other words, is it's being multiplied by 2 every time, isn't it? We're just multiplying by 2 every time. Oh, dang it. Cancel. There we go. -2n. This one, 2, 3, 4, 5. The first term is 1, so it's n plus 1. Sorry, not the first term, the zeroth term. I'm going to always call it the zeroth term. This one is a multiplier. You multiplied 4 times 1 and 4 times 2 and 4 times 3. Notice that these are multiples. That's another way of thinking about them. Whenever you have multiples, you have a multiplier. So it's 4n. And another way to think of this is it's a counting sequence. And this is the first term. So you have to have a starting term, which in this case is 8. And n plus 8 will start counting. We actually started counting at 8 if you think about it, because if the first term is 9, 10, 11, 12, our starting point was literally 8. Lots of ways of thinking about it. Hopefully that all makes sense to you. This is a multiplier. We're multiplying by 56 every time. Those are just multiples of 56, that's all. These are counting, and we started counting where? Well, we started counting at 72, didn't we? Even though we don't see it on there, it's the zeroth term. This one are multiples of 39. Like I said, I wish they would have made it more interesting, but anyway, we're counting by ones still. I'm going to keep an eye on it, and they may change their mind. I just separated that out so you could see it better. It said -96. I was afraid I was going to count it wrong there for a minute. All right, this one are multiples of 64. These are counting by ones, and we started at 42. Even though you don't see it, I know it's not there, but the first term is the next one, 43. This one are multiples of -23. And these are counting one ahead each time, starting at -74. So it's n minus 74. We're getting there. These are multiples of 59. Oh, we did get something a little more interesting. -59n, and the 15th term is going to be -59 times 15. And that's 5, and 4 makes 29, and 0 and 59 makes 8 and 1. 885, huh? But it's going to be negative. Because they want the 15th term, we have to multiply it by -59 in order to get it. 59 times 15. I think that's right. No, I think I got it. The expression in this case is n plus 65, because that's our zeroth term, and we're just counting. And the 68th term is going to be 68 plus 65, which is going to be 3. Here's the 1, 133. And this one are multiples of -10, so we're taking -10 in. Hopefully you can do it in your head and get the 6th term, which is -60. Of course we could have, oh, wow, almost messed it up down here. -60, of course we could have written it -50, -60 and found it that way. These are counting, n plus 6. 6 was our 0 term. And the 10th term, of course, is going to be 16. And these are multiples of 10. That's 10n. And the 9th term is 90. And these are counting forward. We're counting. We're actually counting up. Our 0 term was n minus 71. And our 77th term is going to be 6, isn't it? These are multiples of -31. So we're talking about -31n. And we need to multiply -31 times 35 to get our 35th term. And that's going to be 5 and 15 and 3 and 9. And we get 1085. But it's negative. Don't forget the negative part. And these are counting up by 1. Our 0 term was the one that's missing from the sequence, which is -14. And -14. And our 84th term is 70, because 84 minus 14 is 70. And it looks like we have one last one. We're multiples of -4, so we're talking about -4n. Come on, get in there. And we want the 9th term, which is -36. And I hope you guys will try it yourself. It's a little easier than I suspected, so hopefully it's a nice surprise for you. And I'll see you back again. Bye.